Ever wondered why thermal power plants are so crucial to our modern lifestyle? Well, let's break it down. Thermal power plants are the workhorses of our global energy system. They generate a substantial portion of the world's electricity, powering everything from our homes and offices to factories and industries. How does it all work? By harnessing the heat energy from burning fuels like coal, gas, or oil, these plants convert water into steam, which then drives a turbine to produce electricity. But their importance goes beyond just generating power. They are vital for maintaining grid stability, ensuring that electricity is always available when and where it's needed. Regardless of the time of day or weather conditions, thermal power plants are there to keep the lights on, our computers running, and our factories humming. So, without thermal power plants, our lives would look very different indeed. Now that we understand their importance, what exactly makes up a thermal power plant? Well, a thermal power plant is like a sophisticated orchestra, with each instrument playing a critical role in producing the beautiful symphony that is electricity. Let's take a look at the four main instruments or components in this orchestra: the boiler, the turbine, the generator, and the cooling system. First up, we have the boiler. This is the powerhouse of the plant, where water is heated to produce steam. Picture a massive kettle, only this one's fueled by coal, natural gas, or even nuclear energy. The heat source boils the water, turning it into high-pressure steam. Next in line is the turbine. If the boiler is the heart of the plant, then the turbine is the legs. This mechanical device harnesses the energy from the high-pressure steam produced by the boiler. The steam propels the blades of the turbine, causing it to spin around at a rapid pace. It's this spinning motion that sets the stage for the next act. Enter the generator. This component is the magician of the group, transforming the mechanical energy from the spinning turbine into electrical energy. It's like spinning a magic wheel, where the spinning motion induces a flow of electrons, creating electricity. Finally, we have the cooling system. This component is the unsung hero of the thermal power plant. After the steam has done its job in the turbine, it needs to be cooled down and condensed back into water to be reused in the boiler. This is where the cooling system steps in, effectively closing the loop and enabling a continuous process. So there you have it. The boiler, turbine, generator, and cooling system, each playing their part in the grand orchestra of a thermal power plant, working in harmony to produce the electricity that powers our lives. These are the essential parts that work together to generate electricity in a thermal power plant. How does a thermal power plant convert heat into electricity? Let's start with the first two steps. In the heart of a thermal power plant lies a furnace. This furnace is where the first step of the power generation process begins: the burning of fuel. The fuel can be anything from coal, oil, natural gas, or even biomass. Once ignited, these fuels create a large amount of heat, and this is where the magic begins. This heat doesn't just disappear into thin air. It's put to work in our next step. The heat generated from the burning fuel is used to turn water into steam in a component known as the boiler. Now you might be thinking, we're just making a giant kettle, right? Well, not exactly. You see, the boiler isn't your ordinary kettle. It's a sophisticated piece of equipment designed to withstand incredibly high pressures. The heat from the furnace warms up the water in the boiler. As the temperature rises, the water starts to boil and turn into steam. This steam is not your everyday steam. It's superheated steam, incredibly hot and under high pressure. The creation of this superheated steam is crucial. Why? Because it's this steam that will drive the turbine in the next step of the process, converting this thermal energy into mechanical energy. These steps form the base of the power generation process. Moving forward, let's explore how this steam becomes electricity. Now, we're in the heart of the process where all the magic happens. In our third step, we take the high-pressure steam we've generated from the boiler. This steam is then directed towards the blades of a turbine. Imagine the wind blowing a pinwheel, but on a much larger scale. The force of the steam hitting the blades causes the turbine to spin around at high speeds. This is a beautiful example of how thermal energy is converted into mechanical energy. But we're not done yet. We have one more step to go through. The spinning turbine is connected to a generator. Inside this generator, we have a rotor that's spinning in a magnetic field. Now this is where it gets really exciting. As the rotor spins, it creates a flow of electrons. And what is a flow of electrons? That's right, it's electricity. So in the fourth step, the mechanical energy of the spinning turbine is converted into electrical energy by the generator. The faster the turbine spins, the more electricity we generate. This electricity is then sent through transformers to increase its voltage, making it ready for transmission across power lines to homes, schools, businesses, and industries. And voila! That's how thermal power plants generate electricity. Now that we've delved into the workings of a thermal power plant, what are the key points to remember? Thermal power plants are crucial in our world, providing a significant portion of the electricity we use daily. They are complex systems made up of many integral components. The main parts include the boiler, turbine, condenser, and generator. Each plays a vital role in the process of converting heat into electrical energy. Remember the step-by-step process. It starts with the burning of fuel, which heats up water in the boiler, creating steam. This steam drives the turbine, which rotates the generator, and voila, electricity is produced. The steam is then cooled back into water in the condenser, and the cycle repeats. These processes, happening in unison, are the heart of a thermal power plant. They showcase the marvel of engineering and the power of science. So next time you switch on a light, remember the incredible process happening at thermal power plants that make it possible.